gathered here. It's my immense pleasure in welcoming you all to the last day of AICTE ATAL FDP on Design and Development of Electric Vehicle. So we are on the verge of the last day. And in this session, I am very much happy to introduce my colleague, Dr. Lakshmi Narayanan sir. He is an associate professor in Electronics and Communication Engineering Department of Francis Xavier Engineering College. We are associated with the institution from long back ago. And sir is a graduate in Electronics and Communication from Dr. Sivanthi Adityanar College of Engineering. And he completed his postgraduate MTech in VLSI and Embedded Systems from Dr. MGR Educational Research Institute, University, Chennai. Sir got his doctoral degree in VLSI-based image processing from St. Peter's University, Chennai. His teaching experience spans over 10 years and an industrial experience of 2 years. And he is a recognized EMC certified data science associate. He is a member of various professional bodies and organized various funded workshops and seminars. He has wide publications in the high impact journals in the area of artificial intelligence, deep learning, communication, image processing, and Internet of Things. He has hosted AICTE sponsored STTP and organized various workshops for both faculty and students. His current research interests include artificial intelligence, deep learning, image processing, and IoT. Presently, Star is a reviewer for various publishers such as IEEE, Stranger, iOS Press, and for various Scopus indexed conferences. He has developed many innovative products and also published patents in embedded systems and IoT area. He is a member of IEEE, IAENG, CSTA, and ISRB. He is currently leading the IoT Applied Lab of Francis Xavier Engineering College for the past 2 years. And it's my immense pleasure in welcoming and introducing the resource person of this session, since we were both associated with Francis Xavier Engineering College for a long time. So without taking much of the time, I will hand over the session to the respected speaker, Dr. Lakshmi Narayanan sir. So I welcome you, sir, and the session is yours.
Thank you, Arinayan sir, for an extended introduction about me.
Welcome, sir.
Yeah, thank you. So, good morning, participants. I'm Dr. Lakshmi Narayanan. I'm from Francis Xavier Engineering College, and I've been working there since 2013. And previously, I worked with a few other colleges. So my expertise is embedded system and Internet of Things. I've been nominated as Internet of Things Applied Lab in charge of Francis Xavier Engineering College. And I've been working in that lab for about 2.5 years. So I have a quite a lot of experience in Internet of Things and sensor technologies, because basically I'm a embedded system postgraduate. So my profile will be telling about different areas which I'm interested in, but my main interest is on embedded systems and Internet of Things. So if I talk about Internet of Things and embedded systems, I can't skip sensors in any ways. So uh, I think this particular topic is rightly coined sensor electronic devices. So I think I'll keep the session quite interesting, and it will definitely not going to be bored because we'll see quite a lot of applications of sensor electronic devices which is applied in vehicle
Excuse me, sir. Sorry to
systems.
interrupt. Sir,
Yes, sir.
the screen is not actually visible, sir. I do not know.
I didn't. Yeah, I didn't start sharing
Oh,
the
sure.
screen.
Sorry, sorry for interrupting.
Yeah, no
Sorry.
problem. So the session was planned like initially we start with theoretical part with a few applications of in-vehicle sensor electronic devices, and in the later part I'll make you explore with an excellent online tool where you can develop a few prototype models. So for those who are the beginners in the field of sensors and embedded systems, that will be a big eye-opening for them. So they can even design small sensor electronic devices or embedded systems without much knowledge in
Excuse me, sir.
the coding part. Yes, sir.
Your screen is not visible.
Yes, sir. I didn't start my screen sharing, sir. I'm
Okay,
just
okay.
giving
Okay.
my introduction.
Okay, thank you.
Better I'll start my screen sharing, then it will not be a great problem. So is my screen visible, sir?
Yes, sir. It is visible now.
Yeah, thank you. Yeah, thank you for inviting me for this AICTE sponsored faculty development program on design and development of electrical vehicles. So my topic today is about design challenges for sensor electronic devices. So I would like to thank Dr. Ainidhi Manikam sir, Professor Mechanical Engineering, and the organizing team of Mechanical Department of Francis Xavier Engineering College for inviting me for presenting for this particular session in this August gathering for the FDP session. So as I told, like my topic is about sensor electronic devices in the field of electric vehicles. I'll just start with the basic introduction about the sensor electronic devices, and then let us explore few applications of sensor electronic devices in the field of a few applications, and then later on we'll look into the sensor electronic devices in the field of electric vehicles. So the transportation system has become the fundamental thing in the economic growth of any country. So I think everybody will accept in this particular statement because every year we can see quite a lot of vehicles are being launched from different manufacturers. So all the vehicles which are manufactured will be of different specifications, and it will be having different kinds of applications for making the car a smarter car or a smarter transportation system. So why they are introducing those kind of smarter transportation system is because the modern society is facing quite a lot of problem in this transportation system, but it is not limited to traffic, safety, and pollution. But there are a few more serious problems are there in the transportation system, which needs to be considered. Because of that, what is the better solution to avoid those problems is like introducing the sensor technologies. Because in recent days, the sensor technologies have gained increased attention and importance in modern transportation system. They have for every vehicles which has been released in all the years. In recent days, they are incorporating various sensors so that your vehicle becomes smarter day by day. So the automotive manufacturers are developing in-vehicle sensors and their applications in different areas, including safety, traffic management, and infotainment. So in this session, we'll discuss about how a sensor technology can be integrated with a smart vehicles to achieve sustainable intelligence, and how safety and traffic control and infotainment applications can be implemented for developing a intelligent transportation system. So how we are going to reach this particular goal is through different applications of sensotronic devices in the field of electric vehicles. So to start with, I'll explain about what is exactly a sensor is, because most of you might be new to this particular field, sensors. So a sensor is defined as it is a device that can sense or it can detect the physical quantity like force, pressure, strain, light, etc. So these physical quantities are converted into its electrical signal. So these electrical signals can be measured through that we can measure the physical quantity, right? So normally, what does a sensor module consist of? A sensor module will be consisting of basically the sensor, which is used for sensing the physical quantity. And at the same time, we'll be having some kind of signal conditioning unit. So normally, the signal conditioning unit will be available in majority of the sensors in order to amplify the output which is obtained from the sensor. So why do we need that signal conditioning unit? Does the signal conditioning unit is required for all the sensors? But definitely it is not like that. So most of the sensors would require signal conditioning unit, and few sensors does not require any signal conditioning unit. The output of the sensor can be directly given to a controller, so that the physical quantity can be directly measured through a controller. This signal conditioning unit, the output of the sensor may be amplified, filtered, or modified to a desired voltage. For example, we can take a microphone. It detects an audio signal and converts to a output voltage. But the output of that microphone will be in the range will be very low. That is, the amplitudes will be very low. In order to further processing of those signals, definitely we need a signal conditioning unit. In this place, an amplifier plays the role of signal conditioning unit, so that that amplifier amplifies those signal so that it can be incorporated to a embedded microcontroller, so that it can be processed efficiently. So, as I told, this signal conditioning unit is not necessary for all the sensors. Like we got sensors like photodiode, light dependent resistors, and there are a few other sensors available. For those sensors, we don't require any kind of signal conditioning unit. So the output from the sensors can be directly utilized for measuring the physical quantity. While talking about sensors, we have quite a lot of sensors available in the market. So that we can make use of these sensors for developing prototype models and build various applications. Right, starting from ultrasonic sensor, the ultrasonic sensor is used for measuring the distance between two objects. Second, we got RFID and NFC. These are a few communication related sensors, and we had magnetic sensors. Sensors are commonly used for door accessing and a few other applications. And we have electrical sensors for measuring the current and voltage. We have different sensors available in the field of electric. Then we have leakage levels to measure leakage sensors for measuring the leakage in the pipes. And we have force, load, and pressure sensor for measuring a particular weight of an object. And we have temperature sensor and humidity sensor for monitoring the ambient temperature and ambient humidity. And we have motion and velocity displacement sensors such as accelerometer and velocity sensors are available. And while talking about sensors, camera is also considered as a sensor in the field of embedded system. So these cameras are considered as visual sensors. We call it as visual sensors. And we got acoustic sensors. We got chemical sensors for measuring various gases in the atmosphere or in the field of vehicles in order to measure the emission or emission. We will be fixing up with a few gas sensors to measure the amount of carbon released from the exhaust. Then we have position and proximity sensor. This is also used in vehicles. For this is nothing but the GPS system which has been incorporated in the vehicles. And we got vibration sensors. This also is available in the electric cars and normal non-electric cars to measure the vibration. So using that, we can able to understand whether the car is working properly or is there any defect in that in a particular zone. Then we got acceleration and tilt sensor to measure the axis in which the car is moving on, whether it is moving in a plane surface or it is moving in a inclined surface. So here in this particular slide, we can see almost quite a lot of sensors available. So all these sensors, not all the sensors, most of the sensors are capable of incorporating in a electric vehicles or any kind of automotive vehicles. So while talking about sensor technologies, these sensors are can be deployed in many applications such as healthcare, agriculture, forest, vehicles, and for marine monitoring. So in the case of healthcare, we have quite a lot of applications in the quite a lot of applications of sensors in the part of healthcare. So we commonly the common thing which we know is about the wearables, right? So we'll be having some wearable devices like smartwatches. So those smartwatches are capable of measuring our heart rate, pressure, and then it is capable of measuring the body temperature and SpO2. So everything it can be measured. But we have little more real-time, that is critical real-time applications which involves sensor in the field of healthcare application. On the top right corner, you can see a person is being implanted with some kind of equipments in the body. So this is nothing but it is a glucose monitoring, that is the body glucose monitoring system. So which is incorporated with a sensor that monitors the body glucose. So this particular application is incorporated along with an Internet of Things. So what exactly is happening there is the sensor continuously monitors, that is the implant sensor which has been implanted in the body continuously monitors the body glucose. So if there is any abnormal situation happening over there, it directly intimates the insulin pump module. So this insulin pump module has an inbuilt IoT controller, so that this IoT controller will be intimating some other people who is the caretaker or doctor. So from the doctor's mobile, there is a possibility of injecting a small amount of insulin into the body of the human through this insulin pump. So see how critically this particular sensor is being developed. So there is two different implants. The first implant is to monitor the glucose level, and the second implant to send some insulin into the human body. So this involves various sensors, and at the same time, there is few embedded devices and IoT controllers. So these sensors are nowadays used in life critical applications where this sensors plays a vital role in detecting all the body parameters, which is very critical. Secondly, in the field of agriculture, as we know very commonly, these sensor devices are playing a vital role in recent days. Maybe not in India, in other developed countries, we can see that most of the agricultural fields are now incorporated with various types of sensors and embedded devices. So normally, we can tell that there are few sensors available to measure the parameters which are there in agricultural field. So we got different sensors such as soil moisture sensor, temperature sensor, pressure sensor. So in order to monitor the minerals available in the soil, so we have different mineral sensors, so that these sensor parameters can be incorporated or collected in a controller, and it can be transmitted to a particular farmer or a person who is taking care of that farm. So in case if it is a requirement like that particular field is in need of water or in need of some kind of nutrition, it will be detected through the sensor, and it will be transmitting those details to that particular farmer, so that the farmer can take steps for rectifying those problems. And we have different water management solutions also in case of this agriculture, sensors in agriculture. So a few sensors can be incorporated in the field along with the moisture sensor, soil moisture sensor. So by making those sensors as a nodes of a wireless sensor network, we are just creating a we are going to make use of an embedded microcontroller along with soil moisture sensor. Both combinedly it form as a node. So multiple nodes will be deployed in the agricultural field where the area is big. So all these sensors will be sending the details about the soil moisture of that particular field to a centralized gateway. So the centralized gateway will be analyzing where exactly the water scarcities are there, or which field requires water. So for that particular field alone, we can able to open the valve and we can fill the field with the water. So that water management is also possible through this sensors in the field of agriculture, because not all the fields will be requiring water in every time. So sometimes sun may fall on particular field, so that it absorbs all the water content in that particular area. But few other locations will be having quite sufficient water. So for a particular field, if you need water, definitely this sensor technology along with the wireless sensor networks will be will be applied so that we can cater that requirement. So this is about the sensors in the field of agriculture. So similarly, we have sensors in the field of forest. In recent days, we can see forest fires in most of the places, and people poaching forest trees. So this can also be reduced using sensor incorporation. They will be forming wireless sensor networks of these sensors. Like each and every tree will be getting an implant of a sensor, which is not going to cost very much. It will be incorporated with a sensor which can able to detect the forest fire, and an accelerometer in case if somebody is cutting the tree. This accelerometer can able to detect those things, and in case of fire sensor, if there is any fire happening, that sensor may be able to sense those fires, and it can intimate to a person who is the authority, and he can come and take actions anytime. So this is about forest sensor application in the forest. So for here also, there is no possibility of getting any network inside the forest. So because of that, what we are going to do is what they are doing is they are making some kind of wireless sensor network so that each and every tree will be communicating with each other because it will be located very closely. So in case of Zigbee, so it can transmit data up to 35 meters. So it can transmit data up to 35 meters. So in case of LoRa, that is long range transmission system, it can transmit data up to 1 kilometer or 2 kilometer. So that even if there is no network available inside the forest, these particular sensor devices with that communication module can able to communicate with each other, so that each and every tree communicates with each other, and it can reach the centralized weather station or centralized forest control station. And from there it can be uploaded to a satellite, and so that the authorities can monitor those things which are happening inside the forest, and they can take actions regarding. So in the field of marine also, there are lot of sensors incorporated. You can see this particular device that we call it as buoy, and this particular system has been incorporated with various sensors to monitor the sea parameters. That is, this particular device can able to monitor the fish movements inside the sea, and at the same time how efficiently this particular device can monitor any rise in the level of the sea, or if there is any distraction in the sea's normal movement. So those things can be monitored through this particular type of sensors in marine monitoring. And at the same time, this has been incorporated with the various cell phone antennas, and it can able to monitor the wind, and it has quite other sensors also, which has been working with the solar system, because often we can't change the batteries in this particular device as it is located inside the deep sea. So using this cell phone antennas, it is possible so that the nearby sailing fishermen can make utilize of this particular signals. So for that purpose, we can make utilize of this, and at the same time we can able to monitor the sea pollution inside the sea. That is, in recent days we can see that the sea is getting polluted by dumping the waste inside the sea. That is, few countries are dumping their waste, that is medical waste and other plastic waste inside the sea, so that the sea is getting polluted day by day. So in order to monitor those things also, we are this particular system is will be able to do that. That is monitoring the pollution inside the sea. So in case of vehicles, we have a lot of opportunities for the sensor. So starting from entering into the car to leaving outside the car, we are just experiencing different sensors. So From the starting, we'll be having a automated key. So while pressing that key involves some kind of sensors for opening the door. So once you open the door, it will be intimated in the dashboard that your door is kept open. Until you close the door, those sensors will be sending the signals to the dashboard, so that the door was not yet open, not yet closed to properly. So once you sit inside the car will be intimating you to wear the seat belt. So there is a sensor. So until you fasten your seat belts, the sensor will be giving some intimations throughout. So for this is a few examples of sensors inside the car. Apart from this, we have different sensors like measuring the temperature inside the car. We have wheel pressure monitoring system, airbag deployment system, and anti-lock braking system, GPS system. We have video cameras, we have rear cameras, and we have fuel sensors. We have ultrasonic sensors, we have microphones, we have radars inside. So all those things are incorporated. All those applications are incorporated using some kind of sensors. So for fuel monitoring, there is a sensor to monitor the level of the fuel. For monitoring the tire pressure, we have a tire pressure monitoring system. So for autonomous driving, we have quite a lot of sensor applications such as radar, lidar, and ultrasonic sensors are available, and a few cameras are even involved in for autonomous driving. We have the GPS system to track the position of this car, where exactly the car is moving, or at the same time, this GPS system can be utilized for navigation systems. And we have other sensors such as inertial sensor, gas sensor, ultrasonic sensor for smart parking system, so that your car won't hit any other car or any walls. So for that, we have different ultrasonic sensors. So in the right side, you can see the comparison between automated car or automated electric vehicle and a normal car. So in case of your automated car, your sensors are nothing but your cameras, lidars, and radars. So those things are considered as your sensors. But in case of your normal cars, we people are the sensors over there, and we are the computers inside the car. So we have to decide everything to how to move or how to drive. If there is any obstacle available, we need to take diversion and we have to move. But in case of automated cars, so there are sensors. It can work together to proceed with this automated driving. So here there will be a central processing unit. There is a microcontroller which will be acting as a controller or a computer, which takes care of all the inputs from the system, that is your sensor system, and it will be autonomously moving the vehicle. So in case of a normal car, your actuators will be your steering. But in case of electric vehicle or an autonomous car, your wheels will be considered as your actuators, because there is no effort taken by any human for movement of the wheels towards left and right. So this is about sensors in vehicles. Now let us see few applications, how these sensors are incorporated for in the field of electric vehicles. So in vehicles, sensor technology supports design development of wide range of applications for traffic control, safety, and entertainment. But this is not the only thing aimed for developing electric car and for developing sensor electronic devices inside the car. Currently, there are average of about 60 to 100 numbers of sensors incorporated in electric vehicles or Porsche vehicles. Maybe it has been expected that it might reach more than 200 sensors inside autonomous cars, so that in order to make a car very smarter. So smarter in the case like it must be very safety, and it must support the person who is inside the car. It has to be very comfortable. So on considering all those things only, we can tell that a particular car is a smart car. So currently there are about 60 to 100 sensors available inside a normal car or an autonomous car, an electric vehicle. But in future, there are more possibilities of incorporating like around 200 and more than 200 sensors inside this electric vehicles or autonomous cars. So here we can see the classifications of sensor used in the vehicles. So the categories of sensors are safety, the sensors for safety. Secondly, the sensor for diagnostics. And the third is the sensor for traffic. Fourth is the sensor for assistance. And fifth is the sensors for environment. And the sixth is the sensors for users. While considering about the safety, certain sensors are incorporated inside the in-vehicle, so that those sensors will be taking care of the safety of a passenger who is traveling inside the car. So those are like micromechanical oscillators, which takes care of the timing requirements. Then a speed sensor to calculate the speed. Cameras is for detecting the obstacles, and those who are for some autonomous cars, they are now incorporating cameras. Then radars, laser beams, inertial sensors, ultrasonic sensors for parking, proximity sensors for different door closing and opening applications, and we got night vision sensor. But these sensors are not limited to this particular criteria. We have quite a lot of sensors for this particular safety criteria. So for secondly, for diagnosis, we have quite a lot of sensor like position sensor, chemical sensor for measuring the emission, and we have temperature sensor to monitor the temperature inside the engine or inside the car. We have gas composition sensor to measure the carbon release from the car, and we have pressure sensor to measure the pressure of the tires, and we have airbag sensors. So these things must be all these sensors applications are considered as real time, or that is critical real time applications. And we have traffic sensors such as camera, radars, ultrasonic sensors, and proximity sensors. So those sensors are incorporated to manage the traffic and for the safety driving. So next is assistance is nothing but to measure various in vehicle and out vehicle parameters, that is gas compositions, humidity, temperature, position using your GPS sensors to measure the torque. Then image sensors are there, rain sensors are there, fog preventing sensors are there, and distance sensors are there. So these sensors are incorporated for assisting the person who is driving that car, or who is assisting the passenger inside that car. So other than that, we have environment and sensor and user sensor. Environment sensor is nothing but the sensors which are located outside the car, that is for measuring the pressure, so for measuring the temperature, for measuring the distance, for measuring the obstacles using the camera, and for measuring the weather conditions. So these type of sensors can be incorporated out vehicle, that is these can be kept outside the vehicle, so that that is exterior of the car, so that it can able to measure the environment conditions. And in case of user, we have quite a lot of sensors such as thermistors, electrocardiogram sensors, heart rate sensors. So these sensors are actually optional. So these sensors will not be available in most of the cars. Most of the luxury cars will be having these kind of sensors to monitor the body parameters inside the car for the passenger who is driving or sitting inside the car. So these are the different classifications of sensors which is used inside the vehicles. So while considering about the in-vehicle sensors or the sensors which has been utilized in the vehicles, a few sensors are considered to be a very critical sensor for safety driving. So that are tire pressure sensor. Second is the radar, that is the radio detection and ranging sensor. And the third one is GPS and accelerometer sensor. And the fourth one is camera sensor. And the fifth one is the LiDAR sensor. So the tire pressure sensor is nothing but it automatically alerts the driver using a light, a vibration, or a warning alarm that the tire pressure is low. Even if the tire pressure is high, there is a possibility of getting an intimation to the driver's dashboard. So if possible, I'll show you a small demonstration using a online tool about how this tire pressure sensor works. And secondly, we'll be seeing about a radar. This radar application that notifies the driver that is something is coming close to the vehicle. So this particular radar is used for avoiding like a vehicle collision activity, so that it keeps the passenger safety. Then we got GPS and accelerometer sensor. This GPS and accelerometer sensor are used for positioning the vehicle, where exactly it is moving, and also the orientation and velocity can be measured through these kinds of sensors. So next is camera sensor for monitoring the driver activity, and at the same time it can be used for executing night vision assistance, because most of the sensors are susceptible to environmental conditions. But camera, it can see night vision, so that helps in autonomous car for driving very safely, or detecting any obstacles which is approaching towards the car, and detecting any sort of lane changements. So all those things can be detected through these camera sensors. And lidar is more similar to that of your radar, but the only thing is it can detect 365 degrees, but radar can transmit in a straight line. If there is any obstacle in the straight line, definitely it will be able to detect. But in case of lidar, it can rotate 365 degree, and it can accurately find the depth information, that is the distance information, and it can able to prevent different collision activities which is happening on the roadside. So what is the difference between the radar and the lidar is nothing but the range. So the radar can proceed up to 200 meters, while your lidar cannot go beyond 15 to 20 meters. So the other difference is your radar can pass electromagnetic wave, and it will be receiving the wave in a straight line. But in case of lidar, it will be rotating 365 degrees, and it will be measuring the obstacles 365 degrees which are about to get collided with the car, so that the car can take diversion and it can move safely. So these are the various in-vehicle sensors available inside the autonomous cars. Few of them are long range radars, then we have lidars, and then we have cameras, and we have short and medium range of radar. So in this itself, you can able to clearly see that lidar can find the obstacles in a 365 degrees, 360 degrees. That is, it has been shown in red color. So it can able to trace the obstacle in the 365 degrees, 360 degrees. And in case of your radar, it can detect only in the straight line, because it consists of a transmitter and a receiver. The transmitter will be sending a ultrasonic wave, electromagnetic wave that hits on an obstacle, and it will be reflected back to the receiver, so that through that it calculates the distance between the obstacle and the car. So these are the various sensors which are being incorporated inside the in-vehicle. So here you can see some camera applications for detecting traffic signs, lane warnings, then side mirror surrounding views, so rear view mirrors. So all those things can be done using this camera sensors. And so yeah, that's it. So these are the different cameras or sensors which are used for autonomous drivings, which are kept in vehicle. The best mix of sensors for autonomous driving is, the first thing which is required is an ultrasonic sensor for detecting the obstacles in the immediate vicinity. That is very short distance. If there is any obstacle, definitely this ultrasonic sensor will be helping in detecting those obstacles. So this particular ultrasonic sensors are mostly incorporated for parking assistance. Okay. So secondly, GPS system to calculate the latitude and longitude, and of course the speed of the vehicle can be monitored. And the third is angle and speed sensors to measure the wheel rotations. And the fourth is the LiDAR to allow obstacles to be identified correctly, so that it will be rotated in 360 degrees to identify the obstacles. I'll show you a small demonstration or a small video of how a LiDAR will be working. And we have cameras to classify the objects and other non-objects on the road. And at the same time, it has quite a lot of application for the drivers also. So it can able to identify the activities of drivers, like if the particular driver is being drowsy, it can be easily identified, and it can even stop the car. So those kind of applications can be involved through this camera sensor. So these are the sensors that is a best mix of sensors for an autonomous driving, which are ultrasonic sensors, GPS, speed and angle sensor, LiDAR, and camera sensors. So as I told, like there are a small difference between a LiDAR and a radar. That a spinning LiDAR sensor is better in detecting the object. That is the only advantage of your LiDAR, and it provides a good range and angular resolution. So it is able to calculate the obstacles which is surrounded by the car. But in case of range, your radar's range is greater, which can see about 200 meters, and it is able to measure the radial velocity. And this radar is also very solid, and it can be purchased very cheaper when compared to the LiDAR. So these are the basic difference between a radar and a vision, normal vision. So the range of the radar is quite large, while the LiDAR, in case of LiDAR, it is a little small. And resolutions, that is your radar can travel in a single path, that is in a straight line. In LiDAR, it can travel in a 360 degree. Next is angular resolution. It is possible in LiDAR and it is not possible in radar, but in vision we can see 360 degree what is exactly happening around us. Working in different weather conditions, this radar will be working in different weather conditions, but your LiDAR can't do that. If there is a heavy rain, we can also not able to see what is happening exactly with outside the car. And works in dark. So almost all the radars and radars will be working. Normal human can't see what is happening inside the dark. And work in bright, everybody can work in bright normally. And color and contrast, your vision can see that color and contrast differentiations, while your radar and LiDAR are depending upon some kind of waves and lights, so that it cannot able to identify the color and contrast. Radial velocity, it can measure, that is your radar can measure the radial velocity, while your LiDAR can't measure any radial velocity, or your vision cannot be used for measuring the radial velocity. This is the basic difference between what is a radar, what is a LiDAR, and normal human vision. So next important feature is the tire pressure management system. This is an important sensor electronic device which is there inside in vehicle. So we have a tire pressure management system. That is, there will be a sensor which will be able to calculate the tire pressure and the tire temperature. So all these sensors will be incorporated with a microcontroller and a wireless transmission system. So in case of your normal car, there will be 4 different TPMS modules will be fixed inside the car tire. I think you can see that in the top uh, right corner, this particular tire pressure management system is being incorporated inside the tire. So this module will be consisting of a microcontroller along with a sensor for calculating the pressure as well as the tire temperature. So all those details will be collected, that is the tire pressure and the tire temperature sensor parameters will be collected, and it will be transmitting wirelessly to a centralized receiver. Okay, so in the bottom right corner, I think you can able to see the transmitter as well as the receiver. The receiver will also having I'll be having a receiving antenna and a microcontroller, so that and a display system, so that to just to display what is the tire pressure available in all the 4 tires. So it will be displaying the pressure details of all the four tires. If in case any in any of the tires, if there is any problem or low in pressure or high in pressure or high in temperature, definitely it will be start intimating the dashboard that the receiver module that the tire pressure is low or tire pressure is high. So that can be seen as a warning warning display in the dashboard or in the receiver module that has been incorporated for monitoring the tire pressure. So in the left bottom left corner, you can see how the tires are communicating with the centralized receiver, and how a warning symbol is being created on the dashboard. So the centralized receiver will be receiving all the details from all the 4 sensors. If there is any abnormal activities is happening, or any low pressure or high pressure or high temperature is happening, suddenly it will create a warning on the car dashboard. So this is about your tire pressure management system. So this tire pressure management system, the transmitter unit will be consisting of a small button battery with a microcontroller unit. It might be any microcontroller unit, whichever is smallest, we can incorporate it with that microcontroller unit. And we'll be having a temperature sensor and a pressure sensor. Normally we'll be using MLX sensors, and a few people are even using BMP sensors, so that to measure the pressure of a particular tire. And in the receiver unit, you can see that it will be having a microcontroller unit, and there will be an antenna for receiving all the tire parameters. So it will be evaluated inside that microcontroller unit, and it will be transmitted to the dashboard with a warning symbol through the CAN protocol. So throughout the car, the protocol which is being utilized is your CAN protocol. So from the transmitter to the receiver, so it will be working on a wireless manner. From the receiver to the dashboard, it will be in a wired manner, and they will be following a CAN protocol. So the CAN is some protocol used for transmitting the data from your receiver unit to the dashboard. So all the communications or wired communications which is happening inside the car are following this CAN protocol. So on the left hand side, you can see how that transmitter is being implanted inside the tire, and receiver unit which is incorporated with the microcontroller and the receiver antenna. So all those analysis part will be taken care using this receiver board, and it will be transmitted to the dashboard. So this is about this tire pressure management system. So second critical applications inside the car is airbag deployment system. The airbag deployment system is nothing but it has a couple of sensors incorporated. So you can see any kind of application, it will be incorporated with a sensor and a control unit. Control unit is nothing but a microcontroller involved inside that. So the crash sensor will be identifying if any crashes is available. It will be intimating the controller unit. So controller unit, what it exactly does, it initiates the inflator. The inflator, it automatically starts the process of ejecting the nitrogen gas, and automatically the airbag starts deploying. So these kind of critical applications are also involved using this sensor modules and other microcontrollers, which are collectively we call it as embedded units. So this is anti-lock braking system. This anti-lock braking systems is also involved with a few sensors and a few mechanical equipments. So this particular anti-lock braking system is like whenever a car is being driven in a high speed, suddenly something happens inside on the pathway. Normally we used to put a brake. If there is no anti-lock braking system, the car will lose its control and your wheels will get locked. So in order to avoid this, we have a system that we call it as anti-lock braking system. So that this anti-lock braking system will be working in this manner. That is, on the left hand side, you can see the how it has been how it is working. That is the block diagram of that particular anti-lock braking system. Whenever the tire is rotating, that microcontroller unit will be measuring the speed of the particular tire, and at the same time it will be communicating with the anti-lock braking system. Whenever a sudden brake is being applied, the speed is be reduced drastically, so that will be intimating that anti-lock braking system hydraulics, and it will be pumping that brake slowly, so that the skidding of vehicles will be avoided. So how the hydraulics will be pumping to apply brake is shown in this animation. So that the car will be getting control, so that it will not go out of our driver's control. So this is also an intelligent system which incorporates various sensors and different microcontroller units, so that to avoid car crashing. And camera sensors, we have many applications in recent days, like side mirror cameras. Instead of having a side mirror, there is a possibility of having a camera. In recent days, few luxurious cars are coming with this kind of side mirror cameras. So these side mirror cameras are capable of analyzing the analyzing various things which is happening in the sides of the car, and at the same time this particular camera sensors are able to identify the driver's activity. Like if the driver is feeling drowsy, it is now capable of slowing down the car, and it is possible to stop the car to intimate that that particular driver is feeling drowsy. And it is also used for night vision assistance, because in the night time most of the sensors will be working very normally, so that obstacles can be identified very efficiently. But in case of cameras, we can definitely make use of this kind of obstacle avoidance in the night driving. And the GPS, I think most of you will be knowing, it will be used for tracing the car, or otherwise, or it is used for navigation. So accelerometers are the sensors which is used to detect whether the car is driving on a plane surface, or it is driving on an inclined surface, or it is climbing a hill. So if it is climbing on a hill, there is more fuel will be required. On a plane surface, fuel will be utilized very minimally. So in order to differentiate those things, accelerometers can be utilized. So now to build a prototype model, what we require, or to build sensor electronic devices, what we require. So we require a few things which are we need a controller, we need an actuator, and we need a some sensor, some kind of sensors. So sensors will be monitoring the parameter. Your microcontroller unit will be analyzing those parameters, and these actuators actually plays a vital role in performing the activity which needs to be done. Like if a certain brake is applied, the sensor will be detecting the brake action or tire action. So it will be recorded in the controller, and the actuator is nothing but the hydraulic pump applying the brake, so that the car will be coming into the control. So for those similar kind of applications, these following things are very much required. So the first thing is your controller, second thing is your sensors, and the third thing is your actuators and other power sources, which are common for all the sensor electronic devices which has been there inside the vehicle. So as a beginner, we can go with some sort of development board for developing small sensor electronic devices. So Arduino is actually one sort of development board where the PCB will be filled with all sorts of components such as power circuit, programming interface, basic input and output, LEDs, and IO interfacing pins will be there, so that the user can be very comfortably incorporate various sensors and actuators, and we can make use of this particular sensor, particular embedded device. So this is the basic structure of an Arduino, and there is a possibility of connecting all sorts of digital sensors and analog sensors. We have a possibility of connecting 13 digital sensors in this particular Arduino, and there is a possibility of connecting 6 analog sensors in this Arduino. And other than that, we have power supplies. We have different sort of power supplies. That is, we can give 5 volt, or we can take 3.3 volt. So the operating voltage is around 7 to 12 volts, and the IC inside this particular Arduino board, that we call it as ATMEGA 328P. So this is a main microcontroller unit which is taking care of all the processing activities that is captured from the sensor, and giving instructions to an actuator. All those things are happening using this particular microcontroller unit. So for different applications, like if it is a standalone application, that is it. In case of your tire pressure monitoring system, it has only one single application to monitor the tire pressure. Or additionally, it is just calculating the temperature of the tire. So for that minimum applications, we can go for the mini boards. Like we have Arduino Micro, Arduino Pro Mini, and Arduino Nano. So these are a few options for minimum application. That is, in case of your tire pressure monitoring system, we are just going to monitor the tire alone. So that is tire pressure alone. So in case of temperature monitoring system, we are going to monitor only the temperature of the ambient temperature. So if there is more amount of sensors available, more amount of sensors required for executing a particular application, we can go for either for an Arduino Uno. Uno is a standard board that can be utilized for this particular, in case of if there is a normal number of sensors required. We can go for Arduino Mega. Arduino Mega is nothing but it consists of more number of IO pins, or more number of analog and digital sensor pins are available, so that more number of sensors can be connected through this Arduino Mega. So these are the very commonly available sensors in recent days. Those are temperature sensors, PIR sensors, ultrasonic sensors, and gas sensors. So all those sensors can't be directly incorporated for a real-time applications. For developing a prototype model, these particular sensors can be implemented. So for applying for, if you're inventing some innovations in the car, so if you are going for a patent, so initially they require a prototype model. For that prototype model, we can go with these kind of sensors for that application, particular applications. And other in-vehicle sensors such as radars will be there, and ultrasonic sensors will be there. As I told, like on the right hand side, you can see how the radar is measuring the obstacle. right? On the bottom, you can see the ultrasonic sensor, which comes with the two knobs. One is the transmitter and the other one is the receiver. From the transmitter, it transmits an electromagnetic wave, and that hits on an obstacle and it will be reflected back in the receiver. The time to take, that is the time is calculated from the transmitter to the receiver. Then the distance, that time is calculated for the distance. The time is converted to the distance. So this is how your modern sensors in the vehicle will be working. Now let us try a small demonstration.
Sir,
Yes, sir.
can we have a query session, sir?
Sir, I have a small demo to show.
Oh, sure, sir. You proceed with that, sir.
Yeah,
Since the
shall
screen
we
sharing
complete
stopped,
that
I
and-
thought it may query hours. Sorry for interruption.
Yeah, no problem, no problem, sir. There is an online tool for simulating various applications which involves sensor electronic devices. So one such excellent tool is Tinkercad. So Tinkercad is an online tool which has been developed by Autodesk for performing small or prototype models of sensor electronic devices or embedded devices. So this is the dashboard actually. So while opening this Tinkercad, this is the home page. So what you need to do is you need to sign in either with your Google account or your Apple account, or otherwise you can create your own Tinkercad account using that Tinkercad login. So I'm just logging with my own credentials, that is Google user ID and password. So this is the environment of Tinkercad. So for the people who are interested in 3D designing, you can go for this 3D designs, and a lot of resources are available in online for this particular 3D design. And in case of circuits, that is our aim of creating applications. So so you need to click on the circuits. Arinam sir, is my screen visible?
Yes, sir. It is visible.
Thank you. So here you need to click on the circuits, and you need to click on this create new circuit. So this particular event creates a new workspace for you. So this is your workspace which has been created. So all of a sudden we cannot go and purchase an electronic controller or a sensor from the shop, because most of them would cost very high. So instead of for avoiding those kind of complications, we are having this kind of Tinkercad tool. So this is the environment where we are going to work. On the right hand side, we can see all the components which are there, which can be utilized for building a simple project. So here you can see that Arduino is there. So what exactly will be doing is just click on that particular Arduino, and we have to drag it and place it over the workspace. So if we need any kind of sensors, as I talk about ultrasonic sensor, that is a radar sensor a lot. So this can be brought it in. So here you have two different knobs. This one knob, we call it as your transmitter knob, and the other knob we call it as your receiver knob. From the transmitter knob, an electromagnetic wave will be transmitted. If there is any obstacle standing before this ultrasonic sensor, it detects by this electromagnetic wave will be hitting on that obstacle, and it will be reflected back, and it will be received in the receiver knob. So that through that, the time taken for transmitter to the receiver will be calculated, then the time will be converted to your distance. So I'll show you a small application how this particular ultrasonic sensor will be working. I've already having a few circuits for this. So this you can understand like this is a parking. This is a circuit for parking system. I'll try to reduce it. So this ultrasonic sensor will be coming with 4 different knobs. One is your power supply knob, and the other one is ground. So this power supply and ground will be used for powering up your ultrasonic sensor. Other than that, you will be having a trigger pin and your echo pin in order to initiate your transmitter and your receiver. So here what I'm going to do is I'm just going to show you a parking application, so that some obstacle is actually coming before this ultrasonic sensor. So if it is going to reach a particular distance, automatically an alarm will be blowing, or a small LED indication will be there. Like if he is in a distance, if a particular object is in a distance, it will be displayed in a green color LED. And if it is very close to the car, it will be displayed in a red color LED. So this is a simple, very simple application which can be developed using this Tinkercad tool. I'm just starting the simulation. The coding part is also very simple, and I'll if possible, I'll try to explain. So here, if I'm clicking this particular sensor, I can see the range. I told you, no, it will be in the range will be in a straight line. So in case of your lidar, it will be in 360 degree. So it can measure the obstacles 360 degree. So here, what happens? This particular green color object is actually the obstacle. So here the obstacle is in a quite a good distance, that is in 68 centimeters. So if an obstacle is approaching very closer to the car, what happens? So for example, 100 centimeter. So what happens? Automatically an alarm is blowing, and at the same time this green color LED is turning into a red color LED. So the coding part is also very simple. What you want to know is only the logic behind here you can see some few blocks are involved in developing this code. So if possible, in any other time, we'll see a small workshop on this particular tool. Because of limited time, I'm just skipping all those things. So we don't want to write any sort of codes here. We have a lot of online resources available for building this block codes. You don't want to know about the C coding, C programming coding or anything. What you need to know is just how to the logic behind the particular application, that is the sensor electronic devices. So that is much enough for building this kind of codes using this online tool. So you can ask whether these kind of projects can be directly incorporated inside real-time controllers, but definitely yes. So here you can see blocks and text. So for the block we have created, for the project we have created, this online tool is creating a program for us. So for the people who are non-circuit branches, so these kind of coding will be helpful in developing different applications, because most of the microcontrollers will accept only C programming codes, and here you don't want to know about any C programming, just the logic is much enough. So I'll show you one more application, and I'll try to wind up the session. As I told you, I'll show you about the tire pressure monitoring system, isn't it? So I'll show that alone, and I'll wind up the session, and we can go for question session. Yeah, this is a small application which we created in a short time, that once I get the information about taking a session for this FDP, we created this this. We have 4 different knobs over here. So we are not incorporating any sensor here. We are just manually going to reduce the pressure and increase the pressure, and we are just going to see what happens in the display. So this is how your tire pressure monitoring systems will be working. So I'm starting the simulation here. Here you can start and stop the simulation. So it is showing the tire pressure in all the 4 tires. So 30, 31, 35, and 30. What we have done is like 25. 25 is the normal pressure, and if you are going beyond 30. Going beyond 35, it shows us it is tire pressure abnormal. If you are going below 25, it shows us tire pressure very low. So this application is also possible through this kind of Tinkercad. Here you can see 4 knobs. So these 4 knobs represents the tire pressure monitoring module. So what I'm going to do is I'm physically or manually, I'm just going to change the tire pressure to 53. So here you can see that there is an alarm blowing, and it is intimating that the first tire is having high pressure. The first tire pressure is having a high pressure, and now reducing it. So I am now reduced it to 17. The first tire is having low pressure because the normal pressure is 25. So I have fixed as the threshold as 25. So if it is between 25 to 35, all the tire pressure will be normal. So these kind of applications is also possible through this Tinkercad. If possible, I can if time comes, if any time comes, definitely I'll do a workshop on this Tinkercad. Not only I need to do, because a lot of resources are available in online. You can make use of those things, and you can design these kind of simple applications. So I thought of showing you many applications, but due to time restrictions, I'm just finishing with this particular things. Okay, so thank you very much. If you have any queries, you can just post me.
Thank you, sir. The session was more informative, and technically more input were given regarding an ordinary day-to-day life sensors which have been found in our life. So dear participants, in case if you have any kind of queries, you can interact with the respective resource person, so he will be able to clarify your doubts. You can unmute and you can put your queries, or you can make use of the chat box to post your queries. Sir, can I share the question to you?
Yes, sir.
Sir, there is a question from a participant. What is the wavelength range of light used in Lidar?
Wavelength, the range I can tell you, range is less than 100 meters is the range of Lidar.
Is there any kind of queries? You can unmute and post your queries, or you can make use of the chat box available. So I can wait for a few more seconds. If there is no queries, let me come to an end of the session, so that you can go for a break and come back again for the second session 13. So there's a few queries.
Yes, sir. Battery operated. Most of the tire pressure sensors are battery operated. So while doing service, people are now changing that batteries. So it is costing very less. Normally we'll be using the smallest size of CMOS battery, which we use in the computer. So those kind of batteries will be incorporated for monitoring the tire pressure. So it is not going to cost more, sir. And the modules which we use inside that tire pressure monitoring system are energy efficient, so which requires very minimum amount of energy. Sensors normally it won't cost very high, except a few sensors like critical application sensors such as lidars will cost more when compared with the radars. Then ultrasonic sensors will cost very less when compared to the lidar and radar. So cost wise, most of the sensors available in the market are not more than 500 rupees. When we are going for real-time applications, definitely few sensors will be costing more, because there are much difference between a normal prototype model of sensor and real-time sensor. There is much difference starting from this wavelength and its range. There is more difference.
Sir, these were the questions and you have clarified their doubts. So thank you very much, sir. On behalf of the organizing team, we extend our hearty thanks to our respected resource person, Dr. Lakshmi Narayanan, sir, for providing a most informative and valuable session to the our participants. So on behalf of the team, we thank all the participants for extending their kind cooperation. So please, you join for session 13 by 10:45 a.m. Thank you to our respected speaker and to all the participants. Thank you very much. Have a great
Thank
day.
you, Arinagam sir, for your patient listening, and all the
Welcome, sir. Welcome.
participants in this August gathering. So if time possible, I'll do a workshop for you. If required, you can just contact either
Sure, sir.
Needimanikam
Sure.
sir or Arinagam sir. So I
Sure.
can do a workshop for you in person. Definitely.
Sure, sir. Sure,
Thank
sir.
you
We
very
do.
much. Thank you
Thank you, sir. Thank you.
very much. Thank you very much.
Thank you, participants. Have a nice day. Thank you, sir.